In this section, we'll be writing linear equations in standard form. Now, standard form is a very useful way to write an equation for a line, particularly one situation where we're dealing with vertical lines. You may recall when we're in both slope-intercept and point-slope form, we're required to define the slope of a line, which leads to, well, in the case of vertical lines, division by zero, which we don't want. But if we want to write the equation of a vertical line that passes through the point, let's say the equation of the line that passes through the point 5, 1, and 5 minus 2. How do we write the equation of this line? The first thing we need is the slope. So we know how to find the slope using the slope formula. We subtract the y values and divide that by the difference in the x values. So let's do that. Let's say we have 1 minus a minus 2 divided by 5 minus 5. Cancel these two negative signs. That gives us 3 divided by 0, which this tells us has an undefined slope, or an infinite slope. Okay, there's not a whole lot we can do with this in slope-intercept form or point-slope form. But the good thing about standard form is that we don't need to deal with the slope. Standard form looks like this. It comes in the form a times x plus b times y equals c. And a few notes here: a, b, and c are all constants. They're all three are constants with no common factors. So they're all they don't share any common factors. The constant a is non-negative, so it's either 0 or positive. And one more note that's important: this b right here is different than the b that we saw in slope-intercept form. There we saw b was the y value of the y-intercept. That's actually different here. It's just simply a constant that we're using. So that being said, the line passing through these points 5, 1, and 5 minus 2 is a vertical line passing through x equals 5. X equals 5. So, and that makes sense because if we have 2 points of a straight line that both have an x value of 5, that means it's going straight up and down at x equals 5. So let's take a look at some examples. We're going to rewrite the following equations in standard form, and which is going to be very useful for us later on. So let's say we have the equation y equals 3x plus 6. Now this equation is in slope-intercept form, and we want to convert it into standard form. So what we want to do is we want to get all of our variables on one side, preferably the left side, and the coefficient of x needs to be non-negative. So let's go ahead and do this. We can move 3x to the left side by subtracting both sides by 3x. We have plus y equals 6. Now a, our coefficient of x, is a negative 3. We want this to be a non-negative. We can fix this by dividing everything, all three terms, by a minus 1, and that essentially just changes the sign of these three terms. So we have 3x minus y equals a minus 6. And this is our answer in standard form. All our variables are on the left side, and the coefficient of x is greater than 0, or it's non-negative. Okay, let's do a few more. Let's take a look at the slope-intercept form. Y equals minus 3/4 x, 3/4 x minus 5. The first thing we need to do is move our x over. So we have a positive 3/4 x. We simply added 3/4 x to both sides. Plus y equals a minus 5. Okay, now this answer is fine, but we can actually get rid of the fraction in front of x, which is generally a good idea. We don't like to leave fractions in our answer, so we can actually multiply the entire equation by 4, or we can multiply all three terms by 4. That'll cancel this 4, so we have a positive 3x plus 4y equals a minus 20. We simply multiplied all three terms by 4. And I'd rather have it in this form right here, in standard form, so we don't have a fraction in front of the x. We always want a nice positive whole number in front of our x. Makes things a lot easier to deal with. We actually start dealing with standard form. Let's take a look at another one. Let's say we have y equals x minus 7. Okay, well, we need to move our x to the other side. So we have minus x plus y equals a minus 7. Now we don't want a negative coefficient in front of x. Here we have a negative 1. So let's go ahead and divide everything through by a minus 1. We can do that if we apply this to all three terms. And that'll give us a positive x minus y equals positive 7. We're essentially just flipping the signs of everything in our equation, which is perfectly fine, and this is our answer. Alright, let's take a look at a few more. Let's take a look at some equations in point-slope form. These were in slope-intercept form. Let's convert some point-slope form equations into standard form. So we have y plus 3 equals a minus 2 times x plus 2. Okay, now clearly we actually have a little more work to do when we're converting an equation from point-slope form to standard form. More work than we had to do when we were dealing with slope-intercept form. But the same rules apply, so let's go ahead and move our variables to the left and make sure the coefficient of x is non-negative. So let's go ahead and distribute this minus 2. So we have y plus 3 equals minus 2x. Minus 2 and plus 2 is minus 4. Let's go ahead and move our x term to the other side. So we have 2x plus y. And at the same time, we can move our 3 to the other side. So we're subtracting 3 from both sides. So minus 3 minus 4 is minus 7. We did 2 steps in one. A coefficient of x is non-negative, so this is a perfectly acceptable answer in standard form. Alright, let's do a couple more. Let's look at y minus 1 equals 1/2 times x minus 5. Okay, we have another equation in point-slope form, so let's go ahead and get our variables on the left. We got to get our x out of this parentheses first, so let's distribute the 1/2. So we have y minus 1 equals 1/2 times x minus 1/2 times 5, which gives us a minus 5/2. Alright, now let's move our x term to the left side. So we have a minus 1/2 x plus y. Let's go ahead and move our 1 to the other side, so plus 1 on each side. So we have a minus 5 over 2 plus 1. Let's just write it as 2 over 2. And now we simply need to join these together, and we'll have minus 1/2 x plus y equals a minus 3/2. Now we have a negative coefficient and a fraction for our x coefficient, which I tend not to like. So let's multiply the entire equation by a minus 2. That'll essentially kill the fraction and change the sign to positive. So that'll cancel the denominator, so we'll simply have a positive x minus 2y equals a positive. That'll cancel that denominator as well, so we have a positive 3. And that's a good looking standard form equation. Alright, let's find room to squeeze in one more. Let's squeeze in one more right here. Let's say we have the equation y plus 1 over 5. 1 over 5 equals 4 times x plus 0.75. And that is messy, and I apologize. 0.75. Okay. Again, we want our variables on the left, so let's go ahead and distribute this 4 right here. And at the same time, let's go ahead and convert this 0.7 to 3 over 4. I like to deal with a fraction instead of a decimal here. So let's rewrite the left side. We have y plus 1 over 5. 4 times x is 4x. Plus 4 times 3 over 4. The 4's will cancel, so we'll just be left with 3. And then we want our variable on our left side, so let's go ahead and move x to the other side. So we have a minus 4x plus y plus 1 over 5 equals 3. Alright, let's go ahead and move our fraction 1 over 5 to the other side. So we have a minus 4x plus y equals, let's convert 3 into a fraction with a denominator of 5 so we can handle them together. So 15 over 5, and we're subtracting both sides by 1/5, so we have a minus 1 over 5. That'll give us minus 4x plus y equals 14 over 5. And we have one step left. We want to have a positive coefficient for x, so let's divide everything through by minus 1. Minus 1. We can also look at it as multiplying everything by minus 1. This will give us a positive 4x minus y equals a minus 14 over 5. And that's our answer in standard form. So we have a few extra steps here, but let's not get excited. Point slope form just takes a little bit more time, but it's definitely doable. We know how to do it. So we're converting our equations into standard form, which can be very useful, especially when dealing with vertical lines. So, and we'll actually show you how to derive important pieces of information in the next section. We can derive the slope and the y-intercept form, and we'll go over that in the next video. I'll see you then.